point of this course is going to be not only to explain to you what the Higgs is, what role it plays, but why people were so excited by it. And because this is a lecture course, not a mystery novel, I'm going to give you the answers ahead of time. This is the kind of subject where it repays careful thought. So I'm, in this lecture, going to tell you, try to explain why it was such a big deal, and then in the lectures to come, we'll go through all the details and fill in the story a little bit. So the point is, the Higgs boson is a little bit hard to understand because what we call particle physics is different than what we actually think about as professional physicists. I actually blame the guy named Democritus. Democritus is an ancient Greek philosopher. He is really the father of what we now call particle physics. We don't know what Democritus looked like, but we do have portraits painted that are labeled Democritus, because since we don't know what he looked like, people like to paint self-portraits and call them Democritus. So you'll see pictures of people like Rembrandt with the label Democritus. In fact, we have no idea what he looked like. We do have a nickname that he got. He was known as the Laughing Philosopher. And Democritus had the idea that you see a bunch of things around you. You see water, you see solids, you see air, and the ancient Greeks would have thought these were all fundamentally different things. The atomists, like Democritus, had the idea that in fact they were just a small number of fundamental building blocks that go into creating all of these different substances. They called these fundamental building blocks atoms. Now, sadly, for historical reasons, in the 19th century, the chemists got a hold of the word atoms. And so we now use atoms in our modern language to speak of the chemical elements. But these atoms that we have, the chemical elements, aren't really fundamental. We know that atoms are made of smaller things. What Democritus and his colleagues were really talking about are what we would now call the elementary particles, the fundamental building blocks of nature. And since the 19th century, physics has been trying very hard to look for, to find the elementary particles. Particle physics is a thriving field. We know that atoms are made of elementary particles called electrons. They also have protons and neutrons, which we thought were elementary. Turns out they're not. Protons and neutrons are made of even smaller particles called quarks. And we also have gluons, we have neutrinos, we have muons. There's a whole zoo of elementary particles we will be talking about in Lecture 3. The reason why the Higgs boson is hard to understand is because particles are actually not what the world is made of. We talk about that, we use that all the time, and so when we talk about the Higgs boson, it's a particle, it's a boson, which as we will see is one of the two major kinds of particles. However, that's just sort of a sloppy approximation to the true underlying reality. Our modern idea, the idea that is really centrally important to modern physics, is that the world is not made of particles, but it's made of fields. A field, unlike a particle, is spread out everywhere throughout the universe. It's a number at every point in space and time. A particle has a location, but a field is spread out everywhere and is vibrating, is changing its value. Think of the temperature of the air in the room. At every point in a room, there's a temperature. That's a number. That's a field. Temperature is not a fundamental field. It's a derived quantity that comes from the air, comes from the molecules. The modern point of view on the fundamental nature of reality is that quantum fields vibrating at every location in space and throughout time are the fundamental building blocks of nature. You may have heard the question, is light or are electrons particles or waves? I will tell you the answer. They are waves. They are waves, they are vibrating quantum mechanical fields. What we call particles are just what we see when we look at the fields. That is the miracle of quantum mechanics. That's one of the subtle things we'll have to describe during this course. Now, why is it such a big difference? Why do we care that the world is made of fields versus particles? Well, like I said, when you look at the field, you see it vibrating, you see a particle there, so it makes perfect sense to use the language of particle physics, to say there's an electron particle, even though we really know there's a vibration in the electron field. The one difference is the Higgs boson. The Higgs boson is itself a particle.
Para seguir escuchando este audiolibro gratuitamente, haz clic en el enlace de la descripción y podrás escucharlo completo sin coste gracias a la prueba de 30 días de Audible.